Hey folks, so we are still in section 3.2 and I'd like to look at the height of a projected object example. And first thing that I'd like to point out to you is that you have this equation right here, and this is the generic equation for the height of a projected object, negative 16t squared plus this guy here is called v sub naught times t, and this guy here is called s sub naught. And you can see that my s sub naught is going to be my initial height, and my v sub naught is my initial velocity, my starting speed, my starting height and my starting speed. So if we read the first part of this question, a ball is thrown directly upward from an initial height of 100 feet. So I can tell right then that my s sub naught is going to be 100 feet. With an initial velocity of 80 feet per second, so there's where my v sub naught is going to come from. Take a look at part A. Give the function that describes the height of the ball in terms of time t. So I'm going to take what I highlighted right here in purple, and I'm going to write an equation or a function for this particular example. And so I have negative 16t squared plus 80, which is my initial velocity, t, plus 100, which is my initial height. Part B we're not going to do, but if you did want to do that, you would use the graphing calculator. Part C refers you down to figure 20, which is down below. And it says the point lies on the graph of the function. What does this mean for this particular situation? And the point that we're looking at is this point here, 4.8 and 115.36. Well, if you take a look, we've got our old x's and y's have now become t's and s's, times and heights. And so when I look at this coordinate, that 4.8 is my time, and my 115.36, this is going to be my height. And so the best way that you could say this is at 4.8 seconds, the ball is going to be 115.36 feet in the air. Jump down to letter D. After how many seconds? So let me stop you right there. After how many seconds says that I'm looking for t. Does the projectile reach the maximum height? Maximum we know is another name for vertex. So I'm looking for the number of seconds that it takes to reach the vertex. And then the next question is, what is that maximum height? So not only am I looking for my t value, I'm also going to be looking for my height value. The directions say that I should solve analytically. This is just by hand, show your work. And then it also says to show graphically. I'm not going to do that on this video, but you would just be using your calculator to do that. So then after how many seconds does the projectile reach the maximum height? Remember, you have a shortcut for finding a vertex, and that shortcut is negative b over 2a. So that's going to be the first thing. We're trying to find the time at the vertex here. So negative b over 2a, our b is 80, so that's negative 80 over 2 times negative 16. Simplify your fraction, and that gives you 2.5 seconds. Like I said, I won't be doing that one graphically on this particular video. Part F says, after how many seconds? All right, let's stop right there again. Once again, I'm looking for a t value. Will the ball hit the ground? Ask yourself, how high is the ball when it's on the ground? Well, hopefully you're telling yourself, that's at 0 feet. And so on this one, we would answer this graphically. So we would go to the calculator. Basically, we are looking for this value right here on the calculator. This is where the ball hits the ground. And so you would go and find your zeros on the calculator. We have already talked about that in class, or we will be talking about that in class in the next class period. But what you'll find when you find the zeros in your calculator, you will get 6.0355 seconds.